All right, here's a recording for problem number 17 from our calculus book. In this problem, we're asked to find out how far this bottle floats down the stream when we're given this velocity information. Couple of things to note here. We got to watch out for our units. The velocity is in meters per second, but the time is in minutes. So either we need to convert the velocities to meters per minute, or we need to convert the times to seconds. And so I am going to choose to convert all these times to seconds. And so instead of 5 minutes, I'm going to think of this as 300 seconds, 600 seconds, 900 seconds, etc. When we do the LRAM, the estimation of the area under the curve based on the left hand side, we're going to see that the first rectangle is the one that has the interval from 0 to 300. Now that rectangle is 300 wide, and which of these two values are we going to use? Well, when we do that one, I want you to think of here we are at 0 seconds, here we are at 300 seconds, here we are at 1, here we are at 1.2, and since it's L, we're going to be taking the first of those two values to represent the height, and that one height is going to be 1. In the next interval, we have a width of 300. That's the one that's going from 300 to 600. And the height that we're going to use is going to be the first of these two values, because 1.2 comes earlier before 1.7. So this will be 300 times 1.2. Next, 300 times 1.7, 300 times 2.0 plus 300 times 1.8 plus 300 the width times the height of 1.6 plus 300 times 1.4, 300 times 1.2 plus 300 times 1.0 plus 300 times 1.8 plus 300 times 1.5 plus 300 times 1.2. This 1.2 here is the last number we're going to use. Remember, the last span goes from that time interval, and we're always using the first of the two numbers when we do the LRAM. You may note that every single width here is 300, and so what we end up with, if we factor the 300 out of every one of those terms, we get 300 times 1 plus 1.2 plus 1.7 plus 2.0 plus 1.8 plus 1.6 plus 1.4 plus 1.2 plus 1.0 plus 1.8, written very poorly, times 1.5, or plus 1.5 plus 1.2. Now if we take the time to add up all of these values from 1 to 1.2, we're going to end up getting that number, as I calculated on the side, is 87. And when I multiply 87, oh sorry, not 87, that number is 17.4, and 300 times 17.4 is equal to 5,220, and the units here is going to be meters. The RRAM calculation is similar. The difference being, while the intervals are still 300, we're always going to use the second of the two numbers. And it doesn't take too much to notice that if I get rid of this 1 and I add another 0 onto the end of there, this number is just 1 unit smaller than 17.4, and then the 300 times that 16.4 ends up being 4,920 meters, and you can see that that's what the answer key says as well.